Okay, class. Let's do another problem dealing with method of sections. So in this particular problem, we are asked to determine the force in members CD, CJ, KJ, and DJ of this truss below, and we are to state whether the members are in tension or in compression. Okay, so this is just nothing more than a free body diagram that I drew. Okay, with the again, point A is a support reaction that has two forces acting on it, as you can see here, AX and AY. And then we have another support reaction at point G, and that's only one force acting on it. Okay, so A is a pin with two forces acting on it, and G is a roller, only one force acting on it. Okay, these are your support reactions. Well, these are the supports that hold this structure up. So we need to find their reactions, which are going to be in forces. Okay, supports. Okay. Now, our next step is we want to be able to step 2. You want to be able to find or calculate the support reactions. Okay. So what you can do is you can just take some of the moments about point A equals 0. Okay. And again, I'm just going to abbreviate rather than saying 4,000 pounds or write it all the time. I'm just going to say 4 kips, which means kilo pounds, or I may write it as 4K, which is just also means kips as well, just abbreviated. Okay, so I have here, I'm dealing with this section right here. This is my point of interest. So that's going to be 4K, okay, times 9 feet plus 8K times 18 feet plus 5K times 45 feet minus GY, and that's 54 feet equals 0. Again, I'm starting from my point A here, and I'm moving from left to right. So the first force I see is 4,000, and that is 9 feet away from my point of interest A. It's going to give it a positive moment. That's why I have a positive sign here. Then the next force I come to, as I move from left to right, is 8,000 pounds, and that happens to be 18 feet away from point A. This 18 feet away from point A, it's going to give me a positive moment. The next force I come in contact with is at point F, and that's 5,000 pounds, and that's going to be 45 feet away from point A. Okay, and that's going to give me a positive moment. And then my GY, okay, that happens to be 54 feet away from point A, and that's going to give me a negative moment. Okay, and I've told you in the beginning that I'm taking my moment clockwise to be positive. So anything other than that will be a negative. When I solve for GY, I'm going to get 7.5 kips. Okay. Now my next, I can now do my next equilibrium equation I'm going to use. I'm just going to use some of the forces in the y direction equals 0. I'm going to take from bottom to up to be positive, and the only force here in the x direction is AX, and that's going to be 0. Okay, AX equals 0. Okay, now I can do now some of the forces in the y direction equals 0. Oops, yeah, some of the forces in the I'm sorry, this was absolutely wrong here. This is X, X. This looks like this, and this looks like this. I'm deeply sorry. Okay, so I'm looking at all the forces in the y direction. Okay, and I have AY, it's pointing up, and then my 4,000 is pointing down, my 8,000 is pointing down, my 5,000 pounds is pointing down, and then my GY that I just found is pointing up, and that's going to be 7.5 kips equals 0. When I solve for AY, I'm going to get 9.5 kips. Okay. Now, I found my support reactions. My next step is I want to be able to, step number 3, I want to create a sectional cut at members, what's that going to be? CG, CD, CJ, KJ, and DJ. Okay. So when I do that, you're going to see a sectional cut right here that's already been created. Okay. Because all I'm interested in this member, CD. Okay. I'm interested in this member right here, CJ. I'm interested in this member here, KJ. Okay, and I'm also interested in the member. Let me use this one, DJ. Those 4 members. Okay, so when I do that, I'm just going to create a cut, which I've done. So that cut was like this. Okay, and I'm just going to remove that for now. So, and all I did was just what's in the dashed components are just an extension of that particular frame. Okay, so I'm showing all my forces, um, a section of cut of all the forces. So I need this one, KJ, CJ, CD, and I need this particular force right here, DJ. Okay, so we can move forward, and we can now say some of the forces. I want to use my equilibrium equation. I want to use some of the moments about point C equals 0. Okay, this is my point of interest right here, C. Okay, and I'm taking the moments about that point. Okay, and when I do that, I'm going to get FCD. I'm sorry. That's incorrect. No, because that force, I can't use force CD, right? Because it's going through that point. So I have to use my force KG. Okay, so let me do that. Oops, sorry. FKJ, right? So my FKJ, that's going to give me a negative, right? Point of C. This is my point of interest here. And this is 12 feet, 12 feet away. Okay, so that's going to be 12 feet. Okay, and now what other force? I'm at 4,000 feet, 9 feet away from my point of C. So that's going to be -4, and that's going to give me a negative moment, 9 feet. And I have 9.5. Now my AY was 9.5 kips. We found that for my support reaction. Okay, so that will give us, and that's going to be 18 feet away. It's going to give us a positive moment equals 0. Okay, so I solve for FKJ. That's going to give me 11.2 kips or 11.2 kips, either one. Okay, and that's going to be in tension. Okay, now if I take it a step further and say some of the moments about point J equals 0. Now this is my point of interest right here. Okay, Now, by that being the case, um, I look at FCD, it's FCD right here, for CD, and that's going to be from point J, that is going to be 12 feet away, right? Okay, so, and that's going to give me a positive FCD 12 feet away, right? Minus the next force, as I'm looking to my left, I see 8,000 pounds, 8 kips, and that is going to be 9 feet away, right? From point J. This is point J right here, and it's 9 feet away, and it's going to give me a negative moment, okay? Minus the 4 kips, it's right here, and I'm going to be 18 feet away, and then plus my 9 kips, support reaction 9.5 kips, and I happen to be 27 feet away, and I equal to 0. And when you do the math, your FCD happens to be a negative 9.375 kips, or it's going to be 9.5 kips. Sorry, 9.35 kips. Oops. 0.35. Okay, I'm sorry. 375. 375 kips. And that's going to be in compression because your FCD. Okay. Now, so we found 2 out of the 4. So we need a third one, right? So we know that this triangle here, this is going to be 9. This is 12. And if I reduce it, right? If I reduce it, this is by 3. On each side, it's going to be 3. It's going to be 4, right? And then it's going to be a 5. So I can erase this part right here. Okay, so that becomes for a 3, 4, 5 triangle. Okay, so with that being said, I can now say here, this is going to be F. Let me just back up here. It's going to be This is going to be 4/5 F CJ, and this is going to be 3/5 F CJ. Okay, and now when I come and I want to be able to use my next equilibrium equation, like some of the forces in the y direction equals 0. Okay, I can now look at the forces in the y direction. Well, I could look at, it's going to be negative 4/5 F CJ, right? And I have this 8,000 minus 8 kips, right? Minus 4 kips plus my AY. My AY is right here. Okay, plus, and that's going to be 9.5 kips equals 0. And now if I come and do the math, what that's going to give us is going to give us, I could take this to the other side of the equation, which is going to be negative 8 kips minus 4 kips plus 9.5 kips equals 4/5 FCJ. And then FCJ is going to be 3 point, it's going to be 3.125, okay, kips, and it's going to be in compression. Okay. Now, the last one I need to do for joint, so we found CJ. So we found this so far. we found um, KJ, we found CJ, and we found CD. We need to find this member right here, DJ. Okay, so what we can do is you can actually take and say here, okay, I want to look at joint D. Okay, so this is joint D. Here's going to be force DE, force um, CD, and this is force DJ. So if you use some of the forces in the y direction equals 0, our force DJ happens to be 0. Okay, so this is your answer. Okay, oops, I'm sorry. Okay, so again, the takeaway from this particular, I'm trying to make these videos as short as possible. Um, so forgive me if I'm rushing a little bit. Just don't want it to be so long. But there's some concepts I just need to explain, and hopefully everyone gets this. Is again, we are just trying to analyze just certain members of our frame, okay, of this particular truss in particular, and we just need to analyze only 4 members of this particular truss. So the idea is, why don't we just use a sectional cut rather than using method of joints? And in doing so, when you're taking a sectional cut, you first thing before you do that is you want to calculate your support reactions. Okay. Once you do that, then you take a sectional cut of the area that you're interested in, right? And then you redraw it, kind of give it another free body diagram. Okay. And just keep the side you want. I could have went the other side, but I came from the left side. Okay. I could have came from the right side, but I just chose to keep the left side. Okay, it's up to you. And then from there, you just begin to evaluate using the principles that you know um, in method of joints to just apply here, and then you could find out what are your forces in those members that you are interested in. Okay, I hope this helps. Thank you very much, and thank you for your patience. Bye bye.